Welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. This week we're going to be talking about PCluster Manager. This is a graphical user interface that you can use for managing your parallel clusters in your AWS account. It installs separately into your account and is able to manage your clusters in their full life cycle. PCluster Manager makes it really easy to design, create, and manage future parallel clusters. It lets you have a look at all of the variables you've got in front of you, all of the design decisions you have on the table, such as optimizing your storage for exactly what you need it to be, adding file systems, creating new job queues using new CPUs that you weren't using before. You're just going to find yourself experimenting with a bunch of things and discovering that there are many other ways to optimize your HPC experience. PCluster Manager is being built in collaboration between our solution architects and our engineering teams here in AWS. And so we've got one of our senior solution architects from Seattle, Sean Smith, who used to be one of our developers. He's joining us today to take us through PCluster Manager and in particular around its latest features. Today, we're going to focus on the design, creation, and management of clusters using PCluster Manager. And then in the next episode, we're going to focus on a few other things, some advanced topics. Now I definitely want to get Sean up on this. Hey, Sean.
Hello. Hey, Boo.
Welcome back to the show, man.
Thank you.
Now, you guys have been pretty busy, right?
Yeah, it's been pretty fun. We've been able to build features and make the product extremely usable. Parallel cluster is so powerful in what it can do, but it's sometimes hard to understand what all the bells and whistles are. And by surfacing them in the UI, I think it provides a really great user experience.
Bottom line, PCluster Manager is a GUI that'll help you step through standing up a cluster, managing them, and actually doing some debugging as well.
So if you haven't watched the last video, please go ahead and watch that, because that goes into kind of the installation. I'm going to start here, assuming that you've already installed it, and we'll go through molecular dynamics use case running an application called GrowMax. So the first step is I'm going to click this Create Cluster, and this is going to give me a couple options for how I want it to look. I'll call it HPC Tech Short. And we're going to select from an existing cluster. You can see I've got quite a few of them here. And so if I load in my previous GrowMax cluster, we can step through and it'll preload all of the configuration.
That's essentially just stealing the config file from that other cluster.
That's correct.
And using it as a template to step through this thing. I mean, you're still gonna like for the viewers at home, you're still gonna step through the same steps. It's just that by using that template from another cluster, there's gonna be a bunch of things that are pre-filled in.
That's right. And what you can do is you can go to your favorite workshop for, let's say, running GrowMax on Parallel Cluster, which we've got a great workshop for.
This one.
And download that config and then upload it here by clicking template. I've already got it in a cluster, so I'm going to go and step through this from cluster configuration. Yep. So on the next step, it's going to load in. This is kind of the basic parameters. So what region, what operating system are we running with, what VPC, and you can leave these as default in the template. On the next page, we've got, so for this, we're using a GPU accelerated head node. So we've got a NVIDIA T4. This will allow us to view the results using an application called BMD. And I wanted to call out, so we have a lot of users who don't want to open up the cluster. They don't want to open up any ports on the cluster. And so what they can do is they can just turn on Virtual Console. And let's see, we'll enable DCV, so that'll open up a single port. But using Virtual Console, you can connect to the head node via SSM, which is going to be completely in the browser. You don't need port 22 open. We'll show how that works on the next screen.
Right, and that means you could. I mean, if you didn't turn on DCV here, that cluster could be completely hermetically sealed off from the internet, no access to the internet,
Exactly.
all ports closed, thoroughly
And
secure.
On the HPC workshop site, we've got an example of how you can use SSM port forwarding to keep the DCV port closed as well. So you can completely seal it off and connect via port forwarding. There is a slight performance overhead for doing that, but from a security standpoint,
that's awesome.
Some of the cool new features we've added come down here in the advanced option. So one of the feedback we've gotten from users is they want to specify multiple post-install scripts. So they want to say, okay, I want to enable, for example, Slurm accounting. And I want to do that in addition to enabling like installing SPAC on the head node. And so what you can do is you can add all of these scripts here, and then they're going to get run on the head node. So enabling accounting, installing SPAC. You could give it a directory here to install it. Yeah, so that's one of the cool features. And if you're curious about how these post-install scripts work and want kind of a step-by-step tutorial on how they do that, you can head on over to, we've got this is linked on the GitHub page, and Boof will put the link down below. Yeah. We've got tutorials on how to do each of these things. So for example, Slurm accounting, we've got a step-by-step guide that starts with deploying a database and then goes through grabbing the outputs from that database, adding permissions to your cluster, creating your cluster, configuring it.
Right on. And that makes there's a lot to do. Like to enable Slurm accounting, there is actually quite a bit of work that needs to be done because there is a database that's needed, and you don't want it to be a throwaway database when you throw away your cluster because you want it to be persistent across clusters, right?
Exactly. And so a lot of these steps are like for example, the database, you create it once and then you use it across all your clusters. And that would allow you to run queries about jobs that are running on every cluster. And then it's surfaced in the UI. So it gives you a accounting tab and you can make queries. You can see job cost estimates directly from the UI. So that's one example of a managed post-install script. Another would be cost tracking. So cost tracking adds tags to the instances. So for example, you can specify a project tag and it'll assign all jobs that are submitted with that project tag that tag. And then you can set a budget and you can say, okay, if this project exceeds the budget that I've allocated for it, it'll give the user a warning message, actually an error message. This project A, does not have any more budget allocated for this month. And then you can go in and either adjust your budget or use a different project.
Right. And so this is kind of well and truly in line with the requests we hear from customers to be able to manage their consumption of the cloud, right? I mean, it's worth being. We have to be clear. The dollar numbers that are getting mentioned in here are basically we're just using on demand as the calculator rate, right?
So this is all tracked through Cost Explorer.
Right.
So it's going to be your actual account spend. However, there is a delay there. So just keep in mind there's a few hour delay with.
There's like our billing systems run 3 times a day. And so that can mean that there can be like an 8-hour delay between when you do something and when the spend shows up in Cost Explorer. But still, this is really good stuff because it's going to give folks the telemetry they need to be able to be aware of their costs.
So the next step is storage. So when we configure our storage, I always like to use an existing file system. This allows me to persist a file system across clusters. I've got one already set up that has SPAC installed, and it's got a bunch of SPAC binaries pulled down from our SPAC binary cache. And so that's going to give me basically an entire, if you're used to, let's say, a university cluster or a on-prem cluster, you run module avail and you see all of your packages. And by just adding this file system like that, I can have the same experience. So then on the next screen, I've configured this cluster to have a couple different compute options. The first is this HPC 6A 48X large. And you'll notice when I select this, it's automatically enabled EFA and put it in a placement group. So I'm going to get the best networking performance.
Makes sense. Perfect. And so you've got a C6I queue using on demand. You've got a G40N queue using on demand. You've also got a C6I spot queue.
Exactly. Yeah. So I wanted to show a couple different configurations. Each of these queues, these are queues that you choose at runtime, and I'll show you what that looks like when we go to submit a job. But I can choose to say, let's say I choose my C6I spot queue, and for whatever reason the spot availability isn't great that day, I can say, okay, I want to use the C6I on demand queue instead, and I can do that from within the cluster by just changing really a few characters.
Right. Right. So all of these are queues, just like normal Slurm partitions look like on a normal cluster. They're just different queues. In our case, they're different queues with different resources in the back. And sometimes the difference is not the compute type itself. It's how it's purchased.
Yeah. So next we're going to go to the review screen, and this will give us our cluster configuration file. So if you've used the CLI before, you're very familiar with this. And here we're going to click dry run. So it gives me a couple of warnings here. Well, one is around the key pair. So remember, I selected SSM as the way to connect to it, and it doesn't actually have a key pair. So it's going to warn you about that, just making sure you know that you can connect to it via SSM. EFA validator, so it's going to tell me my C6I instance type, the spot one, I haven't enabled EFA on it, but it supports EFA. So that's really helpful for what we've said, those paper cuts.
Yeah. Did you mean to do this? Yeah.
Exactly. And so this configuration file I can save if I wanted to set up this cluster easily. So I could just select all, copy paste, or download it in the next step. Our next step is we're going to go ahead and kick off a cluster create. So this calls the API and we'll start creating the cluster. You'll see in about 30 seconds or so, it'll jump back to the main screen. Okay, so we're going to put a pause there. Maybe it's a cliffhanger, maybe not, but we're going to stop there. We've now built a cluster, and we've got a cluster running that we can use. We're going to come back in part 2. We're going to talk about a common debugging scenario if your cluster creation event did not work out as you expected. We're just going to cover a couple of common scenarios where that might occur and show you how to use PCluster Manager to debug it. And then we're going to go into job management, visualization, a whole bunch of other stuff. So there's a lot to discover in PCluster Manager, and it's all packed into this one very, very cool project. If there's anything that you really want to see us dig deep into in a future episode of Tech Shorts, another topic you want to see us cover, or something you want to see us cover in a bit more detail, go right ahead and contact us. Our DMs are open here on Twitter. You can find us pretty easily and give us the feedback that we need to hear to make the show more applicable to you. If you like what you've seen today, please click the like button and consider subscribing to the channel and telling your friends about it so that you can follow us as we keep coming up with more stuff that's aimed at making your HPC life easier. Anyway, until then, hope you enjoy using PCluster Manager, and we'll see you in episode 2.